Hello. So today we're going to talk about topic 16, which is working with the intermediate value theorem, or some people call it IVT. It's pretty logically makes sense. Something that you probably have already realized. We're going to talk about the mathematics behind it, as well as multiple representations of how to see it. So I have a couple little blurbs here of situations where intermediate value theorem applies. So let's say you and your friends decide to take a trip to Chicago. During the trip, you see the speedometer was 80 miles per hour. At some point, did your car have to travel 50 miles per hour, right? And ultimately, our answer here is that it does. It has to, right? I mean, unless your friends pick you up at 80 miles per hour and you hop in at that speed, I guess you can try to argue with it. But I mean, ultimately, it's you're starting from a stop, you're going to 80 miles per hour. You have to pass through 50 at some point in time, right? So the answer is yes. Now the question is, how many times did it travel 50 miles per hour? Ultimately, you can make the argument that it's going to happen at least twice, right? If I start at a stop and I end in the city at a stop, I know I have to go up to 80 and back down. I know it's got to pass through 50 miles per hour at least twice. Now, it could be more, but I know it's guaranteed at least twice. Okay. Same idea here, just a second one. So doing chores, you fill up a bucket to the top with water. While carrying the bucket, you realize it has a leak, right? Not a good bucket. By the time you arrive at the desired location, the bucket's only half full of water. At some point, did it have to be 3/4 full? And the answer is yes, right? If it went from a full bucket to 3/4, to a half, it had to pass through 3/4 full at some point. Even if it was for a split second, and it would probably only be for a split second, but it would have to do that. And both of these situations deal with this idea of intermediate value theorem. And more importantly, intermediate value theorem only applies for continuous functions. Excuse me there. It only applies for continuous functions, right? So if you're ever going to use this theorem, you must state, I can't emphasize this enough, you must state first the hypothesis that the function is continuous. This theorem has certain conditions. You have to state that the function is continuous before you go any further, okay? But if you have a continuous function like what's shown, right? So if I have a function at A and I have a function at B, I know it's going to pass through every y value, okay? It's guaranteed to pass through every y value from f of A to f of B. I know it's got to go through every single one. Now, could it go through more? Sure. But a lot of times the functions that they give you are not going to be descriptive enough, okay? The only thing that guarantees is that I will hit every output between f of A and f of B at some point between A and B, okay? That's what this statement is saying, all right? Now, here's kind of some applications. So I have some numerical, some graphical, some analytical. I have a bunch of different representations here. So here is a question. I give you a table of values, and it represents the elevation of an airplane over a 4-hour flight. Okay. Part A says, over what intervals will the airplane reach, or when is it guaranteed to hit an elevation of 1,500 feet? And my first interval is going to be from, now we're dealing with f of x, so I'm going to say it's some x within 30 minutes to 60 minutes, okay? So some interval or some x value within that interval. Now I can also say that it's going to occur from 180 minutes to 210 minutes, okay? It's going to occur between those values. Now, how do I justify that answer? Okay, before you even begin, you must state, even though it's in the question, f of x is a continuous function. Okay, so make that statement first. That is important. On the AP exam, if you don't write that sentence, they are not going to read anything after. Okay, so now as far as my first interval goes, I can say since f of 30 is equal to 11,540 and f of 60 is equal to 20,843, and I'm going to say f of 30 is less than 1,500, which is less than 20,843. We can conclude that there exists an x value. I'm running out of room. I'm just going to keep writing underneath here, such that 30 less than x less than 60. So such that there is an x value between 30 and 60 I'm gonna make an a, and whenever you make a variable, we're gonna describe what that variable is, where a is a constant, okay, between 30 and 60, that will have f of a equal 1,500. So it's kind of a long justification for a very simple problem, right? So f of x is a continuous function, have to say it, all right? And then you can state f of 30 is 11,540, f of 60 is 20,843. You're showing what those two values are. Then you're showing that 1,500 is between those two values. Okay, now I wrote 20,843. You could have just wrote f of 60. My bad. Okay, but then you can make the conclusion that there has to be an x value. In this case, we can call it x equals a. Okay, make sure you define any dummy variable you create where a is a constant, such that any a value between 30 and 60 will have an output of 15,000. So ultimately, you need to state it's continuous. You need to state that there is a value above it. You need to state there's a value below it. And then you can conclude that there will be an x value between it that will produce the output between the outputs. Okay. Does the intermediate value theorem gain that the airplane will reach 40,000 feet? The answer is no. Even though it's continuous, there are no x values produced from our table of values that go above 40,000 feet. Now, does that mean that my airplane doesn't go above 40,000 feet? We don't know that. The table is very undescriptive. But based on the information given, we cannot justify that conclusion. So the answer would be no. And my reasoning would be is because there are no moments of time given where the airplane is above 40,000 feet. Therefore, you can't use intermediate value theorem. Okay. Now let's take a look at this graphical representation. So I have a graph here with a jump discontinuity. And I am going to label this jump discontinuity at, let's say, some C value. Okay. And I'm going to make C is a constant. And it's going to be between 0 and 1, right? So I kind of labeled, I wanted to justify what C was. Now, is there an interval for where immediate value theorem would apply? So you ultimately can just pick any interval of where it's continuous. So it could be as simple as saying from -2, less than or equal to x, less than or equal to a -1. So this interval, intermediate value theorem would apply. And ultimately, the reasoning is because it's continuous over the entire interval. Okay. Now, if you were to say from -2 to c, that's a problem because it's not really defined at c, right? It's got to be continuous over the closed interval. I should make that comment. It has to be continuous over that closed interval, -2 to -1. So we want to make sure those points actually exist. Now, what's an interval where the intermediate value theorem does not apply? Well, I'm just going to keep this simple. I'm going to say from -1 all the way to a +1. And the reason being is because since the limit as x approaches c from the left of f of x does not equal the limit as x approaches c from the right of f of x, there exists a discontinuity at x equals c. So f of x is not continuous from -1 to 1. IVT does not apply. Okay, so there's my explanation here. Sorry for my bad handwriting. But I stated that there was a discontinuity. I even showed why there was a discontinuity, right? We talked about that definition of continuity at a point. So one, I stated that there's a discontinuity, made that explanation, and then because there's a discontinuity, I can state that intermediate value theorem does not apply. Okay. Algebraic representation, right? So use the function, and I have one of these, and I don't know if you remember what this looks like. We covered this a little in like 1.6 or 1.7. You know, at 2, I am going to have at 1, it's going to be open. It's going to look something like this. There is going to be a jump discontinuity, okay? Determine an interval where the intermediate value theorem would apply, just like the last one. I can say from -3, let's say, to 0, right? Why? Because it's continuous over that interval, okay? That would be my justification. Again, you can say, you know, if you wanted to be the best case scenario, since the limit, so I want you to see this explanation here. Since the limit as x approaches a of f of x equals f of a for all, and I'm going to say -3 less than or equal to a less than or equal to 0. So for all a values between -3 and 0, we can say that f of x is continuous over the interval of -3 to 0. Therefore, IVT applies, right? So there's your explanation there. I can show why it's continuous, right? The limit exists, the output exists, and the limit is equal to the output. So that's my definition of continuity for all a values between -3 and 0. So I defined what a was. And then I can state that it's continuous, and then I can state that intermediate value theorem applies, right? So to kind of go on the other end of the spectrum, what's an interval where it doesn't apply? Well, we can say from 0, let's say, to 5, okay? And then I'm going to say here, very similarly, since the limit as x approaches 2 of f of x does not exist, f of x is not continuous from 0 to 5, therefore IVT does not apply. Okay, so something like that. All right, so the key connection here is in order to use this idea of intermediate value theorem, stating that you're going to hit every output between the ones given, you have to state continuity. They're making that connection, and that connection is very strong. You must provide it in order to receive any credit for intermediate value theorem. In a future lesson, I'm going to bring up the 2020 question over intermediate value theorem. I had the pleasure of grading those for the AP exam, and unfortunately, according to the grading rubric, if you did not state this continuity piece, you did not get any points on that question for the AP exam. Okay. Hopefully this helped, and I'll see you again.